All right, this is a quick video on Fortigate SD-WAN and how the minimum SLA meet members acts. A lot of people don't know this, but this is 0 by default for individuals, and I think it's 1 by default for zones. So let's talk about our architecture. So for our architecture right now, we have a host sitting down here. The host is 33.33.33.33. It connects up to a Fortigate AAAA, which goes over some SD-WAN links. It's got a total of 4 SD-WAN links. It goes over to a hub 1 that then goes out to the internet. There's ISP. So basically, all the traffic from this host does not locally egress from AAA. It goes up to the hub and then back out. And what we're going to do for this is we're going to ping 8.8.8.8. So if we come over here and we're on this host, if I do a IP ADDR or a IP DHCP, it should show us that our IP address is that 33 address. Yep, so we are 33, 33, 33, 33. All right, so let's go ahead and get a ping going. Ping 8.8.8.8. Let's do a count of a whole bunch. All right, we've got a count going. So if we look here, we can do a diagnose sniffer packet, any host 8.8.8.8. And we can see that we are going out of our H1 path 1A. So we're going out our SD-WAN links. We come over here and look at our SD-WAN links. We've got our 80 VPN. So we're going out of these H1 paths. We look at our SD-WAN rules. We're hitting this rule here. Our source is 33. We're going to 8.8.8.8. We're going out path number 1A. So let's actually get our debug going here. I'm going to grep that for path. Right, and we see we're using H1 path 1A, and we've got a checkbox next to H1 path 1A. If we drop to our CLI here and do a config system SD-WAN and config service show, we see our 2 SD-WAN rules right here, right? Let's dig into this one here. Edit 1, and let's do a get to show everything. If we do a get, we can see that by default, our minimum SLA meet members is 0. What does that actually mean? Well, that means that at minimum, if these were to fail our SLA, which is hub 1, the minimum we need is 0. What that means is that if all of these fail, we are going to stay in this rule. It is not going to mark this rule as dead and then move on to the next one. So by default, we're going to stay in that rule. So I'm going to go ahead and prove this out. Let's go ahead and bring this over here. What we're going to do is we're going to add latency to our links here. So let's add some latency to this guy. Let's add a latency of 111. Right? We should see our latency pop up really high. We see it right here. We see it pop up, and then we're probably going to see it drop back down. We see it drop back down. Why do we see it drop back down? Is because based on our SLA, I'm going to refresh this screen, but based on this SLA, we've got 2 of our links with high latency, which takes them out of SLA, and we're going to go across our other paths. And you can see that right here, right? We shifted over to 1B. We scroll up here. We're going over 1A, 1A, 1A. We fall out of SLA. We're going over 1B. If we look at our SD-WAN rules, we refresh the screen. We can see we switched over to 1B because the 1A, or both of the A links, are high latency. So now let's add latency to that other link. Right, we're adding latency to the other link, right? What do we expect to happen? Well, we come over here, right? Everything is out of SLA. So intuitively, we would think that, okay, well, if everything's out of SLA, we should fall to our next rule. That is not the case when you have minimum SLA meet members of 0. We are staying within that rule. And you can see a checkbox there. Since we're staying in the rule, it just starts going sequentially because everything is out of SLA. So now we just use the sequence. If we were to come in here and change that, set minimum meet SLA members to 1, where we need to say, hey, we have to have at least 1 within SLA. If we do not have 1 in SLA, mark this rule number 1 is completely dead and move to rule number 2. So let's go ahead and commit that change. We've committed that change, and look, our latency drops. Why does it drop? I'm going to stop this debug because now we're going over the hub 2 paths. If we come back to our rule set here and refresh this, I'm going to go back to performance SLA. You can see all of my hub 1s are dead. Come back here. Guess what? We have no check marks against here. What that means is that it's marked this rule as completely dead, and we're using this rule now. So that is the effect of minimum SLA members meeting. Now I'm going to go ahead and normalize that. Config system SDWAN, config service, edit 1, set minimum to 0, right, which is the default. And we come back here and refresh the screen. We should get that checkbox back, and we do. And guess what? We're going back across hub 1, path 1A, and we have our high latency. So be aware of that. I'd say 95% of the time, I have this set to 1 on my primary rule. Another thing I do is I create a new rule that's called like catch-all. I'll say something like if I'm sourcing from the 33 network and going toward the 88 network, I'm just going to use manual. I'm going to go top down. 1, 2, boom, 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 like that. So something like that would be a good catch-all rule. If you have minimum SLA meet members 1 here, so that would die. And then if I also had minimum SLA meet members 1 to here, that would die, and then I would hit my catch-all rule. There you go.